Geoengineering. Dimming the sun could prevent ice sheet melting. Study finds that artificial influence dims the sun only via decarbonizing but entails high risks, requiring the release of millions of tons of aerosols into the stratosphere. With the Antarctic region's sea ice dropping to record low this year due to global warming and rising temperatures, scientists claim there's no quick fix to reverse the damage done. However, a new study hopes to slow ice melting in Antarctica by dimming the sunlight through technical methods under the subject of geoengineering. Climate researchers have avoided using geoengineering as a climate solution in the past. It's because the field involves high risks and incalculable consequences potentially to be faced by the future generation. Upon researching the solution of artificially influencing solar radiation to prevent ice melting in West Antarctica, the scientists warned of unforeseeable side effects of geoengineering. The study was led by Johannes Sutter of the Climate and Environmental Physics Division, CUP, at the Institute of Physics and the Eschger Center for Climate Research at the University of Bern. Geoengineering to tackle climate change. Sutter cautioned in a statement that the window of opportunity to limit the global temperature increase to below 2 degrees is closing fast. It is possible that technical measures to influence the climate will be seriously considered in the future, he stated. Sutter further noted that it is essential to use theoretical models to study the effects and risks of solar radiation management, SRM. According to a statement by the researchers, SRM is a term used to describe various methods of blocking solar radiation in order to make the Earth cooler. The scientists resorted to geoengineering to avoid abrupt and irreversible climate thresholds, including the melting of the West Antarctic and Greenland ice sheets and the associated meter-high sea level rise. Sutter explains, observations of ice flows in West Antarctica indicate that we are very close to a so-called tipping point or have already passed it. With our study, we, therefore, wanted to find out whether a collapse of the ice sheet could theoretically be prevented with solar radiation management. Solar radiation management consequences. The study is the first of its kind to use ice model simulations which showed the impact of artificially dimming solar radiation on the Antarctic ice sheet. Scientists deployed the SRM model to understand the impact of ice sheets under future greenhouse gas scenarios. The model yielded different results according to the statement. If SRM was applied in the middle of the century and emissions continue unabated, the collapse of the West Antarctic ice sheet could be delayed somewhat, but not prevented. However, if the emissions were to remain moderate, the deployment of SRM could be effective in slowing down or preventing ice sheet collapse. Scientists urged SRM to be employed as soon as possible while emissions can be controlled. This is due to the model calculations which determined that SRM impact would be highest if it occurs as early as possible and is combined with ambitious climate mitigation measures. Our simulations show that the most effective way to prevent the long-term collapse of the West Antarctic ice sheet is rapid decarbonization, researchers stated. They further emphasized that ice sheets could remain stable in the long run if greenhouse gas emissions were reduced to net zero, without delay. Planes releasing aerosols in the stratosphere. According to Sutters, the sun would be literally dimmed by appointing a fleet of extremely high-flying airplanes. The planes would release millions of tons of aerosols into the stratosphere. The approach proves effective only under the condition of continuous climate stability over centuries. It would require technical intervention to sustain an ideal scenario. In case the intervention was discontinued and the greenhouse concentration in the atmosphere remained high, the temperature on Earth would quickly rise by several degrees, scientists asserted. Sutter stressed that the consequences of such a termination shock are only one of the possible dangers posed by SRM. Unforeseeable side effects. Further, the researchers are not fully aware of the potential side effects. From what the scientists know, the SRM model could cause changes to monsoon patterns and changes in the ocean, including ocean acidification as well as atmospheric circulation. In hindsight, the project could have social and political implications as well. Thomas Stocker, professor of climate and environmental physics at the University of Bern and co-author of the study, stated, "Geoengineering would be another global experiment and a potentially dangerous human intervention in the climate system, which should, in any case, be prevented according to Article 2 of the UN Framework Convention on Climate Change." Thanks for watching.